Last week, I promised I'm going to show you how partial fractions can be incorporated with your integration. This is your lightning walkthrough.
Alright, welcome back to another video, another lightning walkthrough. This is Yao Le from Vantage Tutor, a class above the rest. And today, we are going to deliver what we promised last week. Now, last week we talked about how to form your partial fractions and why it could be potentially important for your integration techniques. And you can see that happening right now. In part 1, they're asking you for the partial fractions, whereas in part 2, they're asking to integrate the fractions. Now, the partial fraction part, I'm not going to talk too extensive about it. The student over here has done the cover-up method. You can see he's doing it quite rapidly, quite easily. The only thing to take note of this question is that you have a repeated linear factor, and therefore you're expecting 3 partial fractions, with one of them being the repeated linear factor. And you can see right now, b equals to 1, c equals to 2, and very quickly he's solving for a, which is equals to 1. Now he's expressing it into the partial fraction, and we'll see how that's important in a short while. Now, second part is integration of your fractions. Very often you're going to realize that whenever you're asked to integrate a fraction, you're going to get a ln function. However, in this case, you realize that your numerator is not a derivative of denominator, and hence, very often when you see such a question, you need to go through the partial fraction first. You can see he realizes that the numerator has a factor of 3, for which it factorizes out, upon which he realizes that the fraction that he's trying to integrate is from part A, in which he starts breaking them down into partial fractions. Upon observing the partial fraction, he breaks them up into 3 separate entities for which they integrate each of them separately. The first component, very simply, just integrate into a ln function. Second component, just apply your reverse of chain rule. And then third component, before you apply your ln function integration, before you integrate it into a ln function, you actually need to take out a factor first, such that you get the f prime over fx. And therefore, you get the answer, which is what you see right here. We have come to the end of the lightning walkthrough today. If you like what I'm doing, follow me on TikTok, like my video, share with your friends. I'm sure you'll help them, because I'm trying to get to 10,000 followers. And once I get to 10,000 followers, I'll be able to start a playlist for which it'll be easier for you to navigate through my pages for either PPR, if not the lightning walkthrough. Nothing else. This is Yao Le from Vantage Tutor, a class above the rest. Take care.